All right, hello everybody. So we are going to continue discussing Chapter 3, Section 3. In the previous video, I showed you how to do polynomial long division. And polynomial long division is very useful for what we're going to be doing very soon. The other thing that it has an advantage over what I'm going to show you today is it allows you to divide any type of polynomial by any other type of polynomial. So what I'm going to show you today is I don't want to call it a shortcut, but what it is called is synthetic division. Now, synthetic division is a great tool, especially if you're dividing polynomials by what we call linear equations. Synthetic division is actually limited to only using linear equations to divide by, which I'm going to show you here in a second. But you'll find once you catch on to this that you'll probably use this more when you are dividing by a linear term because of how much faster it actually is. So let's talk about what what synthetic division is. I'm just going to show you exactly how to do this. You could do this by long division, but as you found, I'm sure, from yesterday's video and as well as the work that you were doing, is polynomial long division is a good bit of work, and there's a lot of opportunity to make a mistake because of all the different things that you have to write down and carry and multiply. So synthetic division kind of eases that up a little bit. So let me show you how to do this. The first thing that we do is that we draw a very elongated L like this, okay? So we need this to set up our synthetic division problem. The next thing that we're going to do is we're going to take the numbers that you have here, and we're only interested in the we're only interested in the number coefficients of each term. We are not interested in the variables as far as writing them down. So let's start with the highest power. You can see the x to the fourth has a 1 in front of it, even though it's not there, it is. We're going to put a 1. Now, the next thing to notice is there is no x cubed term. It goes straight from x to the fourth to x squared. When this happens, you must put a placeholder in of 0, okay? Because that 0 actually represents 0x cubed, okay? That is important. You cannot skip that or you won't get the right solution. Now we're going to move on to the x squared. You can see the number in front of the x squared is a -10. So I'm going to write -10 right here. And then we're going to move on to x. You can see that number is a -2. And then the last number is 4. Okay, so what I just wrote down are all of the numeric coefficients of each term. And I wrote this 0 again because there is no x cubed. You do need to put the 0 in as a placeholder. Now, the next thing that we have to figure out is what number we're going to put right out here. And how we do that is we take what we are dividing by, which in this case is x plus 3. You take x plus 3 and you set it equal to 0. Now, as another point that you need to remember, x plus 3 is a linear term. If this said x squared plus 3, we could not use synthetic division to do this. We would have to use polynomial long division. But because it is not x squared, it's just x to the first, we can use synthetic. And that's the downside to synthetic division. You can only do this when you're dividing by a linear term. So when we set x plus 3 equal to 0 and I solve it, I simply get x equals -3. That's the number that we're going to write right here. Okay, and now it's just a matter of actually doing the synthetic division. So when I do this, I'm going to drop the first number. It always drops down. Now I'm going to multiply -3 times 1, which gives me -3, and I'm going to write that answer right there. And now what I'm going to do is I'm going to add these two numbers together. So I have 0 plus -3 is -3. Now I'm going to multiply again. -3 times -3. That gives me 9. I'm going to write that 9 right there. Now I'm going to add these two together. So -10 and 9 is -1. Now I'm going to multiply these two, which gives me +3. Now I'm going to add. That gives me 1. And now I'm going to multiply these, and that gives me -3. The last thing I'm going to do is I'm going to add these two, and I'm going to get 1. So what I want you to see is that you're always adding these two numbers, okay? You're always adding those two together, and then you're always multiplying this number times this number down here to get the next number. And then this -3 times -1 gives you 3. Then we do -3 times 1, which gives you -3, and so on. Now, this is where the answer ends up, which is right down here. Okay, so now we need to make sense of the answer that we got, and here's how we do that. We start from the right-hand side, and we start by labeling the rightmost number with an R. That R stands for remainder. Then we put a C. That C stands for the constant. Then we're going to put an x to the second, and then an x to the third, like that. And what you see is these numbers that we ended up with are the numbers that belong with each of these terms. So what we get is we get 1x cubed minus 3x squared minus x, and then it would just be plus 1 because 1's the constant. And then we have a remainder. And remember what we have to do with the remainder. You have to write plus, and then you take the remainder and you put it over what I divided by. So in this case, I divided by x plus 3. So we make it 1 over x plus 3. Now, one thing to note about this is that this x plus 3 did not divide out evenly. It left us with a remainder. And that happens. That definitely happens sometimes. Now, these slides all just explain what I just showed you. Now, another thing that I want to show you is called the remainder theorem. And what this remainder theorem tells us is that rather than evaluating a function at a number, we can use synthetic division to evaluate the function, and it's much faster. So let me show you how the remainder theorem works. Okay, if I asked you to find f of -2, okay, so if we wrote f of -2 right here, what you would do is you would take, and everywhere where there is an x, you will put a -2. And I'm going to fill this out just to show you. So I'm going to take a -2, I'm going to put it in right there, and right there, and then right there. And then you're going to have quite a bit of PEMDAS to do to get this to simplified so you know what the answer is. Now I'm going to do this a little quicker, but you can see this would turn into -8. Okay, this would turn into 8 times 4. This would turn into -10, and this would be -7. This would be -24. And then this would become 32 minus 10 minus 7. So -24 plus 32 is going to be 8. And then 8 minus 10, whoops, is -2. So that becomes -9. So there's a good amount of work there to put that 2 in and then follow PEMDAS. Hope that you do PEMDAS in the correct order, and then you finally get your answer. So when I plug -2 into that function, I get -9 out. Well, there's a much faster way to evaluate these big, long polynomials at numbers. And the way that I'm going to show you here is to use synthetic division. Okay, so I'm going to write my big L that I showed you like in the last problem. I'm going to put a 3 here. I'm going to put an 8, and then I'm going to put a 5, and then a -7. Now this time we already know what the number is. We didn't have to solve for x. X is already told to us, so it's -2. Okay, so I'm going to do synthetic division just like I did in the last problem. Drop the 3, and then multiply. -2 times 3 is -6. Now I'm going to add 8 and -6. And I get 2. -2 times 2 is -4. Then I'm going to add 5 and -4, which is 1. And then negative 2 times 1 is negative 2. And when I add negative 7 and negative 2, I get negative 9. What I want you to see is that the remainder matches what we got when we put negative 2 into the function. And so one of the cool things about synthetic division is that you can use synthetic division to evaluate big functions at numbers, and it's much faster. Just look at the amount of work that it took to do this, just adding and multiplying, versus all the PEMDAS and the powers, and then you make sure you're doing the order of operations, which is PEMDAS correctly, and to get negative 9. So if you have to evaluate a function at a specific number, the easiest way to do that is to use synthetic division. So there's another little helpful thing about synthetic division. And you'll see why in later videos why this is really important to know how to do this, because it's going to save you a good bit of time. Now, one thing to keep in mind, and what this factor theorem says, is that if you do synthetic division, I'm going to scroll up here for a second, and right here you can see our remainder was negative 9, right? Because remember, we start from the right, remainder, constant, x, and then x squared. But thing to remember, this remainder, if that remainder is 0, that actually tells you that what you divided by is a factor and it will divide out evenly. Okay, and that's pretty important with what we're doing. So this next problem says, show that x minus 2 and x plus 3 are factors, and then find the remaining factors. So here we are, we're finally to where I've been telling you that we're going to be trying to break down these big polynomials. You can see this is an x to the 4th. And we have to break this all the way down to its linear building blocks. Now, the way that we do that is we start picking away the linear factors one at a time. In this case, they gave us 2 of them. Now, if you look at the power here, it's 4th. Because it's the 4th power, that means it should have 4 of these linear factors. We know 2 of them, so we're going to go ahead and divide those out. So I'm going to start with synthetic division, and I'm going to write my factors. Not factors, excuse me. These are the coefficients. I used the wrong term. And then remember, if I want to divide by x minus 2, I have to set x minus 2 equal to 0 and then solve. When I do that, I get x equals 2. So I'm going to do synthetic division with the number 2. The first number always drops, and then we multiply, and then we add. Then we multiply, and then we add. Then we multiply, and then we add. And what you're going to see here is I ended up with a 0. That's good. We should have, because this is a factor, which means it should divide out evenly. There should not be a remainder. Now, here's the thing to keep in mind. Rather than doing this all over again with x plus 3, I'm going to continue dividing it out further. The thing to label this is your remainder, so we're not going to use that in the next division problem. So I'm going to set up synthetic division again, but this time I'm going to set x plus 3 equal to 0, and I'm going to get x equals negative 3. And I'm going to do synthetic division with the number negative 3. So this 2 is going to drop. Then I'm going to multiply. Then I'm going to add. Then I'm going to multiply. Then I add. Then I multiply. And then I add. And look at that. I got another 0. Again, I should have. So this is my remainder. This is my constant. This is my x. This is x squared. So let's make sense of what we just got now. So we have broken down 2 factors out of this. We took out x minus 2, the first one, and then we took out x plus 3. Now what we're left with is right here, okay? And we need to write that part down. 2x squared plus 5x plus 3. Okay, so now I have taken this big long polynomial that was a fourth degree and I've broken it down, and you can see there are two linear terms right there. And what I have left is a quadratic. Now, that quadratic can be broken down using more conventional methods that you have for factoring. In this case, we're going to use ABC method to break that down. So I'm going to do that right up here. 2x squared plus 5x plus 3. 2 times 3 is 6. So the factors of 6 are 1 and 6, or 2 and 3. They need to add up to be 5. So we're going to obviously use 2 and 3. So I'm going to write 2x squared plus 6x, sorry, not 6x, plus 2x plus 3x plus 3, because we use those two. I'm going to group, take a 2x out, then take a 3 out, and then regroup. And so what you can see is I broke this down into these two pieces. So now the final linear factorization of our original polynomial, remember, this broke down into this right here. So we're going to write 2x plus 3 and then x plus 1. This right here is the linear factorization of this original polynomial. And it's broken down into 4 linear terms because it's a fourth degree polynomial. If you were to refoil all of this back together, you would get this one up there. Okay, so now you can see how we're using all these things that we've been working up towards right now. We started by learning how to factor and then different factoring techniques using quadratics. And then I showed you how to do long division on the last video. And now I'm showing you synthetic division. And we're going to use all of these tools to break down these polynomials into their linear building blocks. Okay, guys, that's what I have for you today. As always, if you have any questions, feel free to email me. Have a great day.